Hello everyone, welcome to FA Learning. My name is Rabbi Alam and today I am going to talk about design approaches for a sprinkler system, right? And this is based on NFPA 13 2019 edition, chapter 19, right? So this is the part 1 and part 2 will be coming next week. So if you have not subscribed my channel, please subscribe so that you can get the latest update on various FA topics. So let's start now. Okay, so NFPA 13, it is written based on an assumption for a single fire areas, right? If you can see these areas, right? So this is the most remote hydraulic design area. So we need to supply water for these areas, right? Based on different types of occupancies, what is the area we need? And based on that, we have to design our system to get the correct pressure and flow at those sprinkler, right? So this system is designed, a sprinkler system is designed for two flow. For the sprinkler system, right, based on the hydraulic calculation plus hose allowances, right? These hose allowances for the first aid firefightings or to finally control the fire or extinguish the fire, right? So we have to combine that one along with the sprinkler system demand, right? So we'll talk in a while regarding the requirement of the flow and all for the standpipe system. Okay, so here we have the hose stream allowances for a sprinkler system, right? It is categorized for based on the occupancies, right? For the light hazard, ordinary hazard, and extra hazard. So for the light hazard, right, you can see we have we have four columns here, right? The first column for the light hazard, right? The first column is for the occupancies, sorry. The second one is for the inside hose, and the next one is for the total combined inside and outside hose, and the last one duration means duration of water supply from the pump or from the water tanks to extinguish the fire based on type of fire, based on the classification, occupancy classification of fire. It ranges from 30 minutes for light hazard all the way for the OH 1 and 2 from 60 to 90 and extra hazard 1 and 2 from 90 to 120 minutes, right? So for the light hazard, we need 30-minute duration of water supply for our sprinkler system, right? For the ordinary hazard, we have 60 minutes all the way up to 90 minutes, right? So if you want to select 60 minutes, there is a condition for that one. If you want to reduce the capacity of the water, the tank and all, you can go with the 60 minutes, but there is a condition. This system need to be supervised by water flow switch, and those signals should be constantly attended by a person 24 by 7, so that by doing so, in case of the fire, there is a high chances that the security department or fire department team will come to the scene as soon as possible and try to extinguish fire or control fire manually, right? So for 60 minutes for ordinary hazard and 90 minutes for extra hazard, this system need to be supervised. Although we know all of the system, which more than 20 number of sprinkler that need to be supervised as for NFPA 13, right? So there is no chance for that. There is no chance that you are going without supervised at this 2021. This is not possible, right? So that's all about the duration. Now coming for the inside hose. Inside hose means something that is inside the building, right? So it is in I'm going to talk in GPM. In GPM we have 0, 50 or 100. 0 means suppose your building has no hose cabinet inside the room, so we don't need to add, right? That doesn't make the sense. Or if you have one hose cabinet, so we have to add 50 GPM into the system, or 2 we have to add 100 GPM. And inside hose requirement or inside hose allowance requirement for all the occupancies, light, ordinary and extra hazard, are maximum up to 100. This is the based on the fact at as I said in the beginning, that this is for the first aid firefighting, right? So there is no chances that at one single particular time in a single areas they are going to use more than two fire hose cabinet to extinguish the fire. So this two is enough to extinguish the fire based on the research and all, right? So that's about that one. This inside hose, right? This is all about the inside hose. Now the next column we have total combined inside and outside hoses, right? So if you have outside hoses, so it should be minimum 100 for light hazard, 250 for OH1 and 2, and 500 for extra hazard occupancies, right? Water allowances for the outside hose shall be added to the sprinkler requirement at the connection to the city water supply, right? Or city water mains or a private fire hydrant, whichever is closest to the riser, right? One more thing, if NFPA says that when hose demand is provided by a water supply, that when hose demand is provided by a separate water supply, the sprinkler calculation need not to include the hose allowances in that one, right? And suppose if you don't have any inside hose, in that case also we have to use outside hose requirement, right? We have to use outside hose requirement into the system, and that need to be supplied by this is mostly for the fire department team. They have to come and they will come and they will extinguish the fire, right? Mostly speaking, the outside hose allowances typically receive its pressure from department apparatus, right? And similarly for the inside hose, right? For the inside hose, we are just going to talk about the flow requirement. Even in our hydraulic calculation software, let's say for Elite software, if you want to add, let's say for 100 GPM for inside, we are not going to care about the pressure. We are just including the flow. Let's say that our sprinkler system need is around 350 GPM at some certain pressure. So we have to add 350 plus 100 DPM, which is 450 at the pressure requirement for the sprinkler system. Just consider the inside hose is nothing but a large orifice sprinkler which can supply up to 100 GPM. Just think outside the box. In the warehouses, we have the sprinkler which supply up to 100 GPM or even more than that. So just consider like that and include the pressure only. Include the flow only, not the pressure. That's all about the hose stream allowances, and this is just for table 193312. So the next one we have occupancy hazards sprinkler system design approach 19.3, right? And this is based on three different occupancy classification: light hazard, ordinary 1 and 2, and extra hazard 1 and 2, right? So occupancy hazard sprinkler system design, mostly we have two design approaches: pipe schedule method and hydraulic calculation method. Pipe schedule method means broadly speaking the old method of calculating the flow and pressure to our system when we don't have hydraulic calculation software at those time. Still it is applicable because at some project they might need to install that one, and it need to be checked with the ASJ, the local ASJ, which they are accepting, because we have hydraulic calculation software in the market, and that reduce all the efforts and give the accurate flow and pressure requirement, right? So I'll just add some point with the pipe schedule method as per NFPA 19.3.2, right? So this system shall be permitted as for this following 4 points. The first one, addition or modification of existing pipe, right? If you have existing pipe schedule system, we can add or you can modify that one. Or addition or modification of existing extra hazard pipe schedule. So point number 2 talks about this system is not applicable for extra hazard new project. It might be for the existing one. Point 3 talks about the capacities. The maximum capacity we have 5,000 square feet. It's very small, right? If you see the hydraulic calculation system, the maximum system protection is up to 50,000 square feet almost, right? Around 48,000 or 52,000 square feet. And this looks like just 10% of the dead flow. So The area is very limited, something around 25 meters by 20 meter, that's it. So the area limitation we have. And point number 4 talks about if you are increasing 5,000 square feet. So in that case, we have to meet the flow requirement in table 19.321, and that should be available at a minimum residual pressure, the flowing pressure of 50 psi at the highest elevation of a sprinkler, right? So here we have a table 1932, which says that for the light hazard occupancies and ordinary hazard, we have two occupancies, light and ordinaries. So minimum required pressure we have 15 psi for light and 20 psi for ordinaries is sprinkler, right? Just wait for a moment. I'm just going to pause. So for the pipe schedule method 1932, we have two types of the occupancies, light hazard and ordinary. It is not allowed for the extra hazard occupancies, right? So minimum residual pressure we need 15 psi for light and ordinary hazard 20 psi. Remember, for water spray sprinklers, as for hydraulic calculation, the minimum pressure is 7 psi, but here we have 15 and 20, so it's almost double than that one, and sometimes triple in ordinary hazard. And at the base of the riser, the maximum flow we can go up to 500 to 750 GPM for LH and 850 to 1500 for OH hazard occupancies at the base of the riser. And the duration is 30 to 60 minutes for light and 60 to 90 minutes for ordinary hazard. So that's all about the pipe schedule method pressure requirement. Now here we have a table for light hazard pipe schedule, right? Remember, we don't have to do hydraulic calculation here because it's the oldest method of determining. So what they mostly do, they just take the sprinkler size, pipe size, and how much sprinkler we need, right? So for example, for 1 inch pipe, we can maximum install 2 sprinklers, right? So if this is 1 inch pipe, we can install 2 sprinkler into that. For 1¼ or 32 mm, we can add additional one here. From here, if it is 3 inch point up to here, we can do that one. So similarly, we have to do for steel and copper. Copper is an expensive solution, but we have less friction loss in the copper, right? And then similarly, we have for the ordinary hazard and extra hazard pipe schedule method. Remember, extra hazard pipe schedule method is not allowed for the new system installation. This table, you might not using because you are performing hydraulic calculations in the software, but this is one of the best tool, if you are the new to this industry, if you don't have experience, or you want to learn how to do hydraulic calculation software and how to choose the pipe sizes, right? So basically, base your pipe sizes based on this schedule to your project, and then perform calculation, right? Once you perform the calculation, look at the velocity, pressure, and flow at some time, right? So based on that, you can increase the pipe diameter or even you can decrease the pipe diameter, right? So by doing that, you might save the cost of your project, and you can also save the cost of the pumping capacity and all electricity requirement. Okay, that's all about the light hazard pipe schedule. The next one, we have hydraulic calculation method 1933, right? And we are going to talk about density area curve with the hydraulic calculation method, right? So here we have a density area curve, right? On the x-axis, we have the flow in GPM per square feet. On the y-axis, we have areas in square feet, right? It means design area of the sprinkler system in square feet. Similarly, on the right hand side, we have the unit in meter square for the area of sprinkler operation, and at the top we have density per minute, the other unit, right? So we are just going to focus on GPM per square feet and the area of sprinkler operation. So these are the 3 steps for selecting the design area curve from this one. The first one, determine the occupancy hazard, right? Let's say light hazard, ordinary, and extra hazard we have. Remember, this chapter 19 of NFPA 13 is only based for this 5 occupancy classification: light, ordinary 2, and extra 2. So all 5. It is not applicable for storage application, which all you can find from chapter 20 to 25. That's the point of other times we will discuss that one. Okay, so we have to determine the occupancy hazard, first one, then select the densities and then apply the adjustment, right? Apply the adjustment means, we can add, we have to increase the area or we have to decrease the area based on different application that I'm going to cover in my next class, in my next video, right? So let's say how you are going to select the density area curve. Your project, if it is a light hazard occupancies, right? So let's say this is the curve starting for light hazard all the way from here to here. So you can select any point, right, from here to here, any areas, right? So let's say if you are taking 0.10, most of the people used to do from the bottom, and 1500 square feet. So if you multiply 1500 times 0.10, it is almost 150 GPM, right? And if you want to go at the top, right, so at the top you have to increase the area of operation, but at the same time you are decreasing the densities. So the density is now we have 0.07 here, so multiply 0.07 to 3000. So this is for light hazard. For ordinary also you can use the 1500 square feet, but for the higher densities up to 0.15. If you want to go up to 4000 square feet, you have to carry 0.10 all the way for ordinary hazards too, because now we are increasing the heat release rate from the fire. The intensity of this fire is going higher from light all the way to ordinaries 1 and 2, and then extra 1 and extra 2. Okay, I would recommend you guys to watch my videos on chapter for density, if chapter for occupancy classification and commodity classification. The links are there in the description, so that you can know what are the different types of the occupancies, what are the commodity classification. That will help you a lot, to come to the point. Okay, so that's all about ordinary 1 and 2. Remember, now for extra hazard occupancies, we have to minimum add 2500 square feet, right, from this point. And if you, and that point we have a density of 0.30, right? If you want to choose 0.2 for the extra hazard, but you have to choose the area of 5000 square feet. And similarly for extra hazard group 2, you can see extra hazard group 2 we have 0.40 GPM per square feet all the way up to 25,000 square feet for the minimum. And if you want to go further up to if you want to decrease the densities up to 0.30, you can go correspondingly from here all the way to this point, and then you have to choose a 5000 square feet, right? So what is the benefit of going to the low point of the curve and going to the high point of the curve? I am going to cover in my next videos, most probably within next 1 to 2 weeks. So that is the other case, right? So this is the overall, how you are going to do that one. And point number 3, which is for apply adjustment, right, based on the type of the sprinkler or based on the uh, type of the system, wet, dry and all. Like for the dry system we have to increase the area up to 30%. For high temperature sprinkler we have to increase minus 25%. All those I will be going to update. I am going to upload my next video on design approach part 2 next week, right? Okay, but here is we have some design restriction, right? Point number 3 we talk about apply adjustment, right? So we have some design restriction. Area below 1500 square feet for light and ordinary cannot be used regardless of the adjustment. Do whatever adjustment, you cannot go below 15,000 for light and 2500 for extra hazard occupancies, right? Now the last point, last slide of this one, we have some design restriction, right? When we are using this density area curve or room design method that will include in the next video, let's focus on density area curve. We have to meet some requirement of 1933152 to keep our area of operation for the sprinkler up to from this curve, right? if we are not meeting 1933-152, which talks about 1933-152 talks about concealed space not required sprinkler protection. Now those spaces are constructed by a let's say passive fire protection system, fire resistant materials, and all kind of the masonry walls, column which have sub 2 hours or 4 hour fire ratings, or some kind of the wood treated materials. That's all about the concealed space which not required sprinkler protection. So again, I would recommend you guys to watch my videos on the concealed space not required sprinkler protection for that areas, right? And 93118 talks about a space under ground floor or exterior docks and platform. We don't need to add that one. But keep in mind, if your design area, let's say this is your design area, right? And in those areas, this is your most remote location of 15,000 square feet, and this is for light hazard occupancies, but you have the ceiling and that is not meeting 1933-152, or it is combustible ceiling without any sprinkler system. Then at that point your area of protection is not going to be 15,000 square feet for the light, but it need to be 3,000 square feet, and then multiply this with the 0.10 densities. So now we have 300 GPM requirement for the sprinkler system. Okay, so that's all about part 1 of design approaches, right? Part 2 will be going to be coming next week, same day on Saturday, and I hope you will combine these two videos together to get the knowledge, and I will also recommend to watch my videos on friction loss explained, right, and all the videos related to sprinkler system, because if you are new to this fire protection industry and if you want to gain the knowledge, I will highly recommend to watch most of the videos on design, so that we can get some of the expertise from all expertise to the highest level, right? And last, happy new year, and subscribe my channel so that we can get the latest update on various FPE topics. So take care now, and I see you next time.